Hello friends, welcome to our channel. Here we are going to look at problem 2145, count the hidden sequences. So here we are going to solve it using partial sum. Sometimes also we call it prefix sum. Actually partial sum is more precise, right? So we need some simple math to solve some mathematical inequalities. So here the relevant concept is degree of freedom. So basically here we are given a integer array called differences, right? So this is obtained by considering the consecutive pair differences of a original array, right? So we also further given two integers called the lower bound and upper bound, right? Describes the inclusive range of values that the hidden sequences can contain, right? So we want to return the number of possible hidden sequences there are. If there are no possible sequences, we return 0. So this is exactly the same. Here, there will be one degree of freedom you will see. So here, let's look at the three examples. So I guess after the walkthrough, it's very easy to know how to do the problem. So I regard this problem as more a math problem rather than a coding problem. So in the first example, we can assume that the starting element of the original array is a, right? Because the difference 1, so we a plus 1, right? Then there's -3, then a plus 1 we plus -3, so we get a minus 2. And then we have 4, so from this number we add 4, we get positive 2, so a plus 2. So the four numbers are a plus 1, and -2 and 2. So this is actually nothing, but you start from 0, you can be 1 and -2 and 4. These are the cumulative sums, right? So from this one, there's one degree of freedom, that is one variable a, right? We can choose, but this is determined by the bound of lower and upper. So here among those four numbers, the minimum is a minus 2 and the maximum is a plus 2. So we require the a minus 2 is greater than or equal to the lower bound, and a plus 2 is less than or equal to the upper bound. So this way it gives a is in between 3 and 4. And in view of that a is integer, so we have a equals 3 or 4, two possibilities. So this is example 1. So similarly, you compute the cumulative sum. So you get a is corresponding to a plus 0, right? 3, -1, and 4, and 4 plus 1, that would be 5. 5 minus 2, and be 3. So among those 6 numbers, so the minimum is a minus 1, and the maximum will be a plus 5. So we require the minimum is lower bounded by -4 and upper bounded by 5. So you get a should be in between -3 and 0. So there are 4 possibilities, that is 0 minus -3 plus 1. So all specifically -3, -2, -1, 0. In other words, 4 possibilities. So it's also important to notice example 3. So if you have a as the start of the original array, you a plus 4 minus 7, that is a minus 3, so a minus 1. So this is the minimal, this is the maximal, right? So we require the lower bound is lower bounded by 3 and the upper bound is capped by 5. So you have a must be greater than or equal to 6 and less than or equal to 1 simultaneously. There's no solution, so we should return 0 in this case. So with that said, actually you know how to do that, right? So basically what you want to do is that you get all those numbers 0, 8. So here actually what we need to compute is the difference, right? The difference of these numbers. That's 2. So let me write a1. So actually there's Python function called cumulative, right? Sum. So you can compute that. You can check that. So but here let me write it in an iterative format so that you know what we are doing. So we have a small and then we have a large. So we can set it to be 0, right? Because if it's no, we just get 0. So the current will be 0. So let's do I change the differences to be d just for convenience of writing. So for y in d, so we don't need to pay attention to the indices, right? So then the current will be incremented by this y. This is the computing the cumulative sum, then we get the small. So small will be the mean of the previous state and the current, and the max, so large, will be max of large and current, right? So after this for loop, you are going to get this number. So because we include 0, right? Because this corresponds to 0. For example, you should have mean is -3 and maximum is +4. Similarly here, you should get mean is -1 and max are not mean, so small. And the large will be 5, right? So what we get? So what we want to return actually is this. So we want to return the upper, right? Minus the large, right? Because we want this. We want you solve for all the a's, right? So we want a plus large is less than or equal to upper, right? And a plus small is greater than or equal to lower, right? If there were solutions, actually, so this one, upper minus a should be less than or equal to this number, and greater than or equal to lower minus small, right? So we expect this number should be greater than or equal to this number, right? Otherwise, there will be no solution. So we plus 1, so it's the end minus beginning plus 1. So we just do return to return. If to return is greater than 0. Otherwise, return 0. This is the problem statement, but we can actually shrink this one a little bit. So because we want to return max to return. So if this guy is not greater than or equal to this guy, so this whole thing will be less than or equal to 0, right? So if we return this always work. So it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the cases. So this is for sure ON solution in time. So now let me print out this. Print out the small and large. Small and large. So you'll see what's corresponding to. So we know for the first example, let's see. For the first example, the small should be -2 and the large will be +2. So -2 and +2. And for example 1, it should be -1 and +5, right? So -1, +5. And for this one, it will be -3 and +4, but there's no solution, right? -3 and +4. Yeah, that's basically about it for this problem. As I mentioned, this is more a math problem rather than a coding problem. But if we say it's a coding, it's just a for loop and then update some running variables. So this, in other words, this is rather straightforward. With that said, I guess that's it for this practice. Thank you for watching.